Welcome to the first international webinar. This is the first of the SZ4D international webinar series, and the basic thinking behind this series is that SZ4D is an effort to improve our understanding of subduction zones around the world, and that requires an international conversation around the world, kind of by definition. And so that as an international scientific community, we can begin to evaluate our collective portfolio of instrumentation, observations, and questions, and think about what it is we all would like to do next. And so to kick off this seminar series, we have Sergio Ruiz from the Universidad de Chile, and sorry for my pronunciation here. That's going to be, I think, a continuing theme of this international webinar. You will listen to me mispronouncing people's names from a variety of places around the world. The next earthquake component of this series will be on August 28th, and that will be Shuichi Kodera from JAMSTEC in Japan. I think that one is unlikely to be in the same time slot because this is a pretty inconvenient time for that end of the Pacific. It's 3 a.m. in Japan right now, so we will probably be modifying the timing of that slightly, but you can mark your calendars for August 28th. In between now and August 28th, every other week, we're going to have international webinars from the other components of SZ4D. So in 2 weeks from now, which is July 31st, we will have the magmatic systems group will be having a speaker, and 2 weeks after that, which is August 14th, we will have the seascapes landscapes group. So it's going to be every other week proceeding on out. Okay, so today's speaker is, as I said, kicking off the series is Sergio Ruiz from the Universidad de Chile. He's an associate professor. He did his first degree in civil engineering in 2002 and received his PhD in 2012, which was based on work both at the Universidad de Chile and IPGP in Paris. He is currently the director of the geophysics program there. And I just met him personally for the first time about 10 minutes ago online. But I'm very familiar with his work because I think he published perhaps one of the most important papers we have seen recently on the subject of subduction zone earthquakes, which is the 2014 science paper on the precursors to the Iquique earthquake, which I think was a real turning point in our all collective discussion about the possibilities of earthquake precursors. It really propelled us into the modern era of this discussion. So without any further commentary, let's get started. I ask that you put your questions into the chat. You may ask clarifying questions if you like during the talk, and I'll try to find a moment to alert Sergio to those questions. And substantive questions, please hold till the end. And Sergio's aiming for about 40 minutes. So hopefully there'll be plenty of time for those questions. Okay, so Sergio, it's all yours.
Thank you very much, Emily. Thank you at all for the invitation to also for stay here. And I share my screen. Okay. Okay, I think that you see my screen. I don't know where I put this one. Maybe smaller. I prepare a timeline about the Chilean subduction earthquakes. This is a little different than a PowerPoint presentation because I will try to show how our understanding about the earthquakes changed along the time, and especially centered in the Chilean earthquakes. And maybe when you think about the Chilean earthquake, do you think in the Nazca South American? Excuse me, question. Do you see my mouse?
Yes.
Yes.
Okay, thank you, thank you. I'm sorry. But Chile is very, very long, almost 4,000 kilometers from subduction. And south of Chile, in this zone, also there is some subduction between Antarctic plate and South America. And also in this zone, there is a transformant fault, also around 1,000 kilometers, because the Scotia plate moves in this direction faster than South America. In this zone also there is some seismicity. The rate of this seismicity is lower than this place. Then in general, we work in here because here occur this large earthquake, this megatrust earthquake, and we have more seismicity. Then in this presentation also, I will speak about this zone. Like this zone is very long, I did a first introduction to explain that we, in general, we divide Chile in 3 zones. This one we call Northern Central Chile, excuse me, Northern Chile, here Central Chile, and here Southern Chile. In Northern Chile, if you look these circles are the seismicity from last 12 months, earthquakes larger magnitude 5. I put here a picture of I take this from Wilbur 3. And these green dots, there is many there. All these are intraplate intermediate events, are earthquakes that happen at 100 kilometers. This is the northern Chile. In central Chile, here's a color like yellow, orange, are interplate events that happen in the contact. And in the southern Chile, we have less events, almost very few. But this zone is the zone where the largest megatrust earthquake with 1,000 kilometers.
Sergio, I'm sorry, you're breaking up a little bit. Do you think you could turn your camera off and maybe that would help?
Yes, and maybe there is okay. It's okay there? Or turn off?
Yeah, turn off your video camera and turn off your video, and I think that might improve. Let's hope that improves. Okay?
Okay.
Please continue.
Okay, thank you. Okay, then we have this subduction that is in between Nazca and South American plate, and here is a little division. This is not picture, these lines are length ruptures of the historical earthquakes. The largest in the northern Chile was 9 in 1877, and after there are several earthquakes that we name like only earthquakes. All these are earthquakes magnitude around 8. In this presentation, in the last slide, I told you about this one that happened here, Iquique. If we move to the south, we have central Chile that is important for us because the big cities are there. Here is Santiago, that is the capital, the biggest city of Chile. Valparaiso, that is other important city. And in this zone, in the last time, we have this earthquake that the rupture length are yellow. Many earthquakes around magnitude 8, and almost 300 years ago, a very large megatrust earthquake that happened there. This earthquake was probably an earthquake magnitude 9. And for recently studies, the paleoseismological studies show that this big earthquake in central Chile occurred in a period that the window is 200 to 500 years. Then at this moment, unfortunately, probably a big earthquake could occur in central Chile where there is the main cities. And finally, the southern Chile is these zones where it's controlled by Valdivia earthquake that is 1,000 kilometer length of rupture, all this zone. And in the last year occurred this Chiloé earthquake was a magnitude 7.6 that occurred there. In central Chile, excuse me, I forget to mention that I also speak about this monster that is looking now, but also occurred 5 years ago, Illapel earthquake, an even magnitude 8.3 in this zone that we call North Central Chile. And obviously in this zone that for us is South Central Chile occur Maule earthquake, other megatrust magnitude 8.8. This is a little the configuration of Chile that is very long, and we need to do some specific differentiation between northern, central, and south and southern Chile. I'm sorry for this. It's necessary maybe to understand. Then, well, the paleoseismological studies start now. The first was in 2005 with the study of Marco Cisternas and Brian Atwater and many others, and they studied the recurrence of a Valdivia earthquake, and they found that this megatrust earthquake occur in these zones probably each 300 years. These studies, there is now more in Chile, and we have that this megatrust earthquake occur recurrently some several hundred years of recurrence. There is, then we have in one zone some megatrusts, but for several years, for 200 years, maybe we have many earthquakes that are magnitude 8. These are maybe recent conclusions because now they start to do paleoseismic studies, especially along the coast of Chile. And in this timeline, I move one of these 8 earthquakes. This was a Valparaíso earthquake that happened in central Chile. Mostly of these earthquakes are interplate. Obviously, this is one of them. This occurred in the contact of Nazca and South America plate. And this is important for us because Valparaíso at this time was very important. It was a big city with many business, with many important people living there. And what happened this earthquake was, this city was destroyed, especially by the effect. But anyway, unfortunately died many people and some important people. Then like died important people for this earthquake. The Chilean government impulsed the creation of the National Seismological Center that was funded in 1908. This is important because the first director was Montesus de Valor, and French scientists, seismologists, and very good seismologists, and he deployed in Chile seismological stations, and also he did a compilation of the all historical earthquake. And at this moment, I think that it started the most regular study of the earthquakes in Chile. But this earthquake is important, but to go fast in this timeline, we move obviously at the most largest earthquake in the modern times, Valdivia earthquake. And the earthquake, unfortunately for all us, in Chile at this period was deployed some strong motion instrument, but during all this sequence, any of these instruments work. Then we don't have any data about the strong motion of this instrument. And when I speak about last mega earthquake that occurred in central Chile in 1730, almost 300 years ago, maybe we need to do the next question. we now have the instruments to record it well, a mega thrust earthquake, an earthquake with a rupture length more than 600 kilometers, because for Valdivia earthquake, we record this earthquake, and we don't understand then how is his rupture. We have some ideas that now also are need to do rethinking how was the rupture of this earthquake, because the few observations we have are about the uplift and subsidence of generated this earthquake, mainly in the Chilean coast. This is southern Chile. This is Chile. This is, and these dots, well, are events actually. But these lines imply in this case subsidence, and these are uplift. And this is the proposition of Plafker and Savage after to recopilate all the information about, like I said, uplift and subsidence. With this information, we can construct, we can build, we can know how is the rupture of this earthquake. Because the data for this earthquake at this observation, and also some mariograph that was recorded in the ocean. Well, this is a change. But for example, for the observation of Plafker and Savage, they was very careful about this data, and they observed that this earthquake has started with an earthquake magnitude 8.1 that started 33 hours before, was a magnitude that occurred in the northern zone. And for example, in his work of 1960, Plafker and Savage described that in this zone were an uplift that is different of megathrust Valdivia earthquake. It's different of the 19.5 magnitude earthquake. And only this year we did the first slip distribution of this earthquake, and we can suggest that maybe the most important foreshock of the history of the seismicity is there in the deeper zone of the plate contact. And after of this earthquake that was 21st of May, there are many other large earthquakes. And some minutes before the earthquake, start like Professor Kanamori described with a large slope deformation. Then he can see in a strain seismogram that was recorded in Pasadena. And this is the other very important data that we have. And unfortunately, we don't have many more, but with this information, now we can understand that Valdivia earthquake is more complex than we think for all this time, because all this time we think that we can model Valdivia earthquake using uplift, subsidence, and mariograph, but maybe, like is proposed by Professor Kanamori and Luis Rivera, also the Valdivia earthquake that's occurring in this zone, the movement is coupled, it's involved also this very large crustal fault that is the name Likinyovki. Likinyovki is a crustal fault, the almost 800, 200 kilometers depth. And Professor Kanamori, again, this strain meter, they propose that the rupture of Valdivia earthquake maybe is not only of this type, where South America move in this direction, if maybe also there is a movement, the type strike slip associated to this large fault that there is in this zone of Chile. They propose there, and also they looking again in 2017, the largest aftershock of Valdivia earthquake. And also they propose that this 7.7 aftershock occur in the Liquiñe-Ofqui fault zone. Then now we have Valdivia earthquake that occurred in 1960s, and we don't have many information because at this moment we don't have the good seismological stations, and we don't understand well how the physical rupture of this earthquake may be the most important for the seismologists and for the people earthquake, because if we ask also if other 9.5 can occur in Chile and other subduction plates, the answer is why not? Maybe if this talk I give in 20 May, any person can say has occurred on an event magnitude 9.5 because 1,000 kilometers is we don't observe before. But now we observe there. There is other largest earthquake in Chile that occurred in the past that we observed with the paleoseismological studies. And the main question is, yes, maybe this can occur. And I think that we need to instrument, we have deployment, the instrument to record that well this future megatrust. Then, well, Valdivia earthquake has some surprise. Unfortunately, this data, that the astrometer that recorded this earthquake in Pasadena, it's looking again for Professor Kanamori, Luis Rivera, Sophie Lambot, and now we understand that the Valdivia megatrust earthquake is, at least we can say that it's a very complex earthquake. Not so simple like this, apparently. And also, there is aftershock in the Liquiñe-Ofqui. Then what happened with the Liquiñe-Ofqui? Liquiñe-Ofqui is there, and we know that here earthquake in 2007, an earthquake magnitude 6.2 with a swarm of events, but it's possible a large earthquake there? Maybe. Now we're studying this fault, and we are founded some repeating earthquakes that are these stars. These squares are the data that we have now. And we can observe that Liquiñe-Ofqui is moving with repeater, maybe in slow sleep movement, and also with ordinary events. And the other question that we can do in these 3,000 or 4,000 kilometers of subduction of Chile, if in Chile there is a non-volcanic tremor, some people that study there, the only evidence was proposed by Professor Ide and Gallegos in 2012 and 2013, and they found no volcanic tremor in the zone of these orange dots. And now this year, thanks to the deployment of the OBS for Japanese group, we found also non-volcanic tremor in the Chile triple joint. And now with this station, we are looking apparently tremor in all these zones. Then in Chile, maybe there is no volcanic tremor, then there is a movement that in general are slow, how this movement interact with, how is the interaction with the Liquiñe-Ofqui fault zone. There is many questions that maybe we can try to understand before of the earthquake occur, because for the people, we need to do prepare for the earthquakes. Then we don't need more surprise. This is an interesting work that is working for Miguel Saez, that is a PhD student. And now I move very fast to the 70s and 80s, where the teleseismic data improved along the world. Then many earthquakes were well studied in Chile. They can observe different groups, especially Kanamori groups, Raúl Madariaga groups, study almost all the events around magnitude 8 that occur in Chile during this period. And they propose also the first interaction between earthquakes. For example, in this picture, of Luciano Astis and Iro Kanamori, then proposed that there is a relation between intraplate earthquake, interplate, and other rise earthquake. But I don't know, it's very complicated to use the words, but maybe unfortunately for us, not for the people, during this period, there is not megathrust earthquake in the world. Now I jump to the other earthquake in Chile. There is many earthquake magnitude 8, but in this case, I put this one that was in 1985, magnitude 8 that occurred here in central Chile in the contact between Nazca and South American plate, because this earthquake was well recorded by strong motion. But when we can see this strong motion has a very complex signal with many bursts of energy. And when we look at the teleseismic inversion, this don't fit. There is it's true that in the strong motion there is more information, especially for the high frequency, but like at this period, this instrument don't have absolute time. We don't work with this one to understand well what's the seismic rupture of this earthquake. Anyway, I think that for the Chilean earthquakes, this is the first earthquakes that we recorded well in the near field and show that the complexity of the subduction earthquakes is very high, because some events pose bursts that maybe in a simple form we can speak that this earthquake has many asperities. I don't know, it's very complex to understand this earthquake thinking in the high frequencies. And now I jump over 10 years, move to earthquake that occur in northern Chile, in Antofagasta. Only show this earthquake because at this period, in 1995, in Chile start the satellite data. And this is the first earthquake in Chile that was recorded by GPS. And also here you can see an infragram that is allowed to study this earthquake. I put this picture of Chile, but there is many groups that work studying this earthquake using this data, then open a new generation of kind of the study of the earthquakes, especially for the Chilean earthquakes. And now we are in 1995, and then we will need other jump. In this case, we jump maybe that I hope all you heard sometimes. That is the Maule megathrust earthquake with a magnitude 8.8 that happened in the 27 February in Chile, 2010. And this earthquake was well recorded by the GPS. Unfortunately, the strong motion recorded this earthquake, but was all the strong motion that recorded the Valparaiso earthquake in 1985, then are strong motion that don't have absolute time. And also we lost here a good opportunity to study in near field megathrust earthquake, but at this moment, the GPS changed evolution, the capacity to record the data. And many of these GPS, that here is the vector, the ecosysmic displacement for the Maule earthquake, some of these GPS, all this arrow is in a site of GPS, and some of them has a very high sampling rate, 1 Hertz. And if we look how is the movement, for example, I know it's very small, but there is the Constitución GPS that is there probably. This is the ecosysmic movement, but also here, plotting this at 1 Hertz, we can see how is the displacement when we have here the seismograms for this earthquake. And now with the GPS, also we can observe the dynamic rupture of this megathrust earthquake, and also how is the geodetic movement or the static movement that give the the GPS data. With this GPS that I think works very well for Maule earthquake, we can observe that maybe several surprises. First of them, with this data, obviously several groups did some inversions that this one was of the first. After actually there is many inversions. I think that maybe 100 works about the sleep distribution of Maule, some with the GPS, also with the teleseismic data, also with the mariograph data, some joint inversions. Mostly of the sleep distribution are similar. The most inquietant or most, or the surprise probably, is not at this period, but the reanalysis after of Tohoku earthquake showed that also this Maule earthquake also moved close to the trench. At this period, that is very close, we think that the megathrust earthquake don't move close the trench. This is changed, that all this we can study not with the GPS, also the best approach is with the tsunami information, because in Chile there is not, at this period and now, there is not a permanent GPS deployed in the ocean. Then we only have in the near field a partial observation that are the stations deployed online. This earthquake also maybe is good forecasting, I don't know, but the 2009, the group that one of the group that deployed GPS in the southern Chile showed, or looking the velocity vectors of the GPS, they observed that different velocities here, that this velocity implied that this zone was very coupled, and that the zone of the South America and Nazca was coupled. The only possibility that in this zone happen next earthquake, and then propose the 2009 that an earthquake occurred in this zone as large as, excuse me, this, as large as an 8 or an 8.5. The earthquake was largest. Then the forecasting maybe is partial forecasting, but anyway, this is a very good approximation. And now we have many coupling maps using this technique that consists in to know the velocity that is moving South America, but with this we can know how coupled is South America with the Nazca plate. Skip this one. And again, I moved to 2000, here is not the year, I moved to 2012. Why I moved to 2012? Because like 2010 didn't work well recorded in near field, in real time. The strong motion don't have absolute time. The broadband instruments recorded, but the electricity was turned off. There was many problems with the deployment. There is few stations. Anyway, again, the government impulsed the creation of the improvement of the before national before of service seismological, national service seismological. And now in 2012, they changed to National Seismological Center, deploying many seismological stations. And now these are the stations we have. From 2012 at, I think that 2014, 15, in 2 or 3 years, around 120 stations were deployed along Chile. Maybe you remember Chile is very long. 4,000 kilometers. There is 2 islands. These are broadband and strong motion recorded in continuous time. thing that we don't have before of Maule earthquake. Then if you ask me, Maule earthquake was a precursory signal? I don't know. And then you can ask me, then why not we look for the continuous data before of 2007 February? Because the continuous data don't exist. Then we lost again opportunity to understand what happened with the precursories because this megatrust earthquake. At this period in 2010, the completeness magnitude in the zone of Maule earthquake was 4.5. Then we don't know if before Maule earthquake occurred many events magnitude 3. Never, we don't know. Then, and this was because at this moment, our service seismological was not prepared by a megatrust earthquake. Now we have all these stations that is a much better situation, but obviously if like Chile is very long, we have some gaps. For example, here is 100 kilometers, then this network for sea is very good, but with this network we can't answer if in Chile there is tremor in this zone. It's very complicated. We need densify or deploy a station for very long time to answer. Some question is the contact is movement like a slope slip events. Now we are better, but I think that we need more to answer questions that are necessary to understand well the seismic hazard in Chile. Well, for the GS, the situation is almost the same. Here there is more colors because some stations are the CSN, all the stations are the CSN. The data are in this web page that is here. It's available to download. There is other colors that are GPS from international groups, and some of them there is not available for all the people, but all the GNSS data for the CSN are available in this web page, and also, and also this data are available, all this data are sent to IRIS repository. Our polite is that all the data should be open. Also, the National Seismological Center is in the University of Chile, but is a public institution. Then our data are available for all of you. If you can try to understand the physics of this subduction, welcome. The data are available for all of us. And like I mentioned, the GPS was recorded very well Maule earthquake. And then we can look this picture. This picture, again, the GPS is the movement, the GPS, but in this case is the post-seismic of Maule earthquake, 5 years after Maule earthquake. Here is we remove the trend of the velocity of the convergence. Then we can observe that the post-seismic that we expect is movement where the earthquake occur in this zone. But also we observe a little vorticity here. There also a warning, there is a change of the scale. Then the orange arrow is bigger than the red. And actually these orange, yellow are very small, but there is a change in the orientation. And it's very peculiar, this observation, but if you remember, maybe not, I said that all this is central Chile, and this part is northern central Chile. And in this zone that is separated from Maule earthquake, there is some distance, 200 or 300 kilometers. The Illapel earthquake that was a magnitude 8.3. Then there is a clear coincidence between Illapel earthquake and this change in the orientation of the post-seismic movement of the GPS along central Chile. If we look at the velocities, the displacement of the stations that are located here in the zone where happened the Illapel earthquake, we can see that is moving. This is the north. this is moving in one direction, but the trend changed when occurred the 2010. In the east-west also there is some change, but it's more complicated to see. For example, in this picture, we can see a little change. Anyway, in the north-south is more clear, the change. Then we propose that the Maule earthquake influence at the Illapel. Both there is some kind of the interaction. Maybe Illapel occur anyway, but after Illapel occur something that both did some interaction. Now there is some groups that modeling this interaction using viscoelastic process, numerical program, and apparently there is, the connection exists, but obviously we need more work because the viscoelastic parameters are very complicated to fix, but I think that at least this observation is very, for me, very impressive. We need obviously to understand more, understand what is the physics that occur, the physics that occur here, but we have this observation thanks we have data. If we don't have this GPS data, we don't have this observation. Well, this picture, maybe I jump for the time. And also, Illapel earthquake was recorded by the network that mentioned of the strong motion, this very dense network I will show in the Google map, but here we can see that unfortunately in this zone there is no strong motion instrument because the complexity of the Illapel earthquake, it's noisy in high frequency. In the back projection, that is possible to see some jump. For example, the rupture started here in the epicenter, move to the north to the west, but here there is a small jump in the back projection. And if the back projection show this, the strong motion, I think that can reflect this movement. And yes, for example, if we take this strong motion, we can observe this kind of event. And after two largest jump of the energy, then what we did, and now we try to using this data to start to model a dynamic modeling of this earthquake, because the physical question we need to understand that this one, that is clearly, at least for me and P and S wave, and this is clear, that is like a foreshock for the largest earthquake. That is foreshock start the rupture or the rupture start there, because in the time that the colors are the time, in the time the rupture start, move here, and in some moment jump there. There is a connection between them. For this, we need to do some dynamical models, and these are working with the IDEO Aochi. We put some nucleation phase for this first foreshock, and then a second foreshock, and our conclusion now is that the first foreshock is not related with this jump. Then probably the earthquake start, the largest earthquake start when they start from here to there. This probably there is no connection between them. This is our dynamic model. This earthquake don't transfer the enough stress to trigger a magnitude 8.2 or 8.3. This only can do if we have, again, a strong motion instrument. If we have a strong motion instrument, we can understand better the dynamic of the nucleation of this earthquake and understand better the physical dynamic of this earthquake, allow to understand better how is the early warning works for this earthquake, because here this, again, Illapel start very, very slow. And for example, for several seconds, the GPS that is located there in the same place of the strong motion start to move. Then if we use early warning for the first seconds, we can observe that the Illapel just there was only a magnitude 7. No, there is no information about a bigger earthquake because the star is not connected with the largest slip rupture. This is, for the moment, our conclusion about this dynamic modeling, but again, we have not too much data, then maybe we can discuss if our proposal is correct. Here there is unfortunately gap of the stations. And now also very fast, because probably you don't remember, but when I showed at the first slides the southern Chile earthquake, I show you an event that occurred here, that this like pink color is the slip distribution of Valdivia earthquake, and here occurred in 2016 an earthquake magnitude 7.6 in a zone where there is not many earthquakes during almost 60 years, because this zone was in the post-seismic of Valdivia. Again, when we look in the GPS data, this in this case are years, we can observe a different trend produced after 2010 earthquake. This station in particular is in Spanish, the city is Puerto Montt is there. And we observe a jump. Then for this earthquake, we propose some similar to Chile, to Illapel, that Maule earthquake affect a biggest zone during this post-seismic, probably by the viscoelastic process, but I don't know. It's necessary to do some numerical analysis in more study, but the observation for me, it's clear. Also, the GPS is very careful about the processing, but there is some change. Maybe it's a little more, a little larger, but there is some change after 2010 for southern Chile and also for northern Chile in relation with the Maule. And now I move all of the end of the presentation, move to the other important relation that was again an observation with the GPS data. One of the first stations GPS antenna deployed in Chile was in Iquique. And this station was deployed there, as the map is increased. Is there. Is almost in front of the slip rupture of the Iquique, that is this yellow. Iquique earthquake was a magnitude 8.2. And in this zone, there is in 2005, an event that occurred at 120 kilometers, an event that occurred in the Nazca Plate, an event magnitude 7.8. The name is Tarapacá earthquake, an earthquake magnitude 7.8 that occurred in 2005. This red color here in this figure, the Jorge, are the intraplate intermediate earthquake. If we look at a profile here, we can observe there. Sophie Pereirat, when he studied this intraplate intermediate earthquake, proposed that the rupture is the subhorizontal plane, because she localized this aftershock using double difference, and she proposed the rupture is there. Anyway, this earthquake that happened in 2005 in the Nazca Plate at 100 kilometers, after this earthquake, the movement of the GPS located in Iquique also changed its trend. And again, we can observe that this is the movement of this station in Iquique to the north, but maybe to the east, to the west is the west. There is a clear movement in one direction, and after 2005, the movement moved and the trend changed. Like all the things, there is unfortunately a gap here of the data, but I think that this is a robust observation also. The GPS also changed his movement. In this case, product generated by an intraplate intermediate earthquake. Then also we show this one and this picture also I put in the material supplementary for the paper that I mentioned Emily, but I think it's a very good observation that after Jorge Jara and Soquet studied very, very well, and they propose and almost confirmed that there are a relation between this earthquake and there, that after 2005 start decoupling in the Iquique zone. Then maybe Iquique earthquake started not only 2 weeks before, maybe several years before, and was triggered, I don't know if there is a best word, by an intraplate intermediate earthquake. Now there is other works that Professor Buchon did. Then also he proposed that there are some relation between intraplate earthquakes and interplate earthquakes. And again, this observation is only possible with this data, the GPS, that also we observe in some GPS, in this case is 2 weeks, we observe now a clear movement in the station that in front. And maybe it's not clear. This is also, of course, a very big discussion, but also I don't put, but also during this period, thanks to a network that in this case is the IPOC network that was deployed around 2005 to 2010 by French and German group, especially the GFZ group. They deployed many seismological stations, broadband and strong motion. And using this data, we can observe that there is many repeating earthquakes, many of them during these 2 weeks and also before. Then also not only for the GPS data, also by the seismological data, we can propose that some slow sleep start before. At this moment there is many problems, so many discussion, but I think that with all this study that working in more detail, maybe it's more clear that Iquique start before. I don't have time, but like it's important, 30 seconds or a little more, to only say that it's necessary also to understand well what is the marine profiles in our subduction, where the contact occur. Here is a work of the Andrei Maximovich, that is a research of our department. Then he take all the segment profile available that are all these lines, and he can observe that the rheology of the for arc is very different, and he proposed 3 different groups. The frontal accretionary prints, that is a seismic. This zone that he proposed that in a different zone where there is a many fractured earthquake. Here occur many of the foreshocks, mostly of the foreshocks, and in this zone, more in the deeper, occur the main shock. Then probably also in this subduction earthquake, there is a relation with the stress conditions that are triggered by the different rheology of this zone. And for this also, I think that we need to work more for the dynamic modeling, that we put different strike condition or friction, different friction law in different zones of the contact plate. And finally, I moved to the 2017 only because this earthquake occurred in Valparaiso, was smaller. For us, it's very smaller, at 6.9, but I show you because when we have a good station deployed, well deployed, and in this case, we have a station just in front of this sequence that start with a swarm that start 2 weeks before of the 6.9. We also, when we look the GPS data, we can observe that movement to the west to this station. Then 2 or 3 days before of this occurrence of the 6.9, we observe a slope slip that also was confirmed by many repeaters events that occurred during this week of the seismicity. Then if we have some more GPS, we can control better these earthquakes that also are smaller, but allow to understand how is the nucleation process of these subduction earthquakes. And finally, the conclusions. I'm sorry for the information. Maybe like English is not very well, don't understand well all, but I show you several earthquakes, and all these earthquakes some surprise. We have surprise when we have well recorded earthquake. When we don't have well recorded earthquake, we don't have surprise. And for example, I take again, I don't put here, sorry, this picture of the ice, Wilbur 3, and take the last 12-month earthquake magnitude 6. There is several in Chile. These two are magnitude 6.7 and 6.8. And in this case, we're looking for the GPS data, but like the GPS data were not in front. We don't know if there has some slow sleep or some nucleation phase. Then we have, I think, more station to understand better all the seismicity that happen regularly in Chile, not only on land, also below the ocean, because we need a better azimuthal distribution of the station. Well, thank you. Thank you for your attention. If I can, if you have some questions, I try to answer.
Thank you very much. So we do have a little bit of time for questions, just a few minutes, but stick them in the chat. And if we don't get to everybody's questions, we'll be sure to forward the chat to Sergio so you can continue the conversation after the seminar. Okay. So go ahead. First, can you read, oh, they're coming in fast and furious. From Francisco Dragada, 2 questions. How much more monitoring instruments do we need to be on the same level as Cascadia or Japan? Let's say 2, 3, 5 times more. Second, is there a temporal gap between the 1995 Antofagasta and the 2010 Maule earthquakes? But there was some large events that were recorded with seismic INSAR GPS, like the 2007 Tocopilla and the 2005 Tarapacá. Is there a lesson to learn from them? What do you have to say?
Yes. For Cascadia on Japan, obviously we need to improve our density of the stations. Our density is not good. Actually, in this map, our network in general works well around an 80 or 70% of the stations. Then, when we look the closest stations, our number is 40 or 50 kilometers. The distance among them, then it's largest to observe smaller earthquakes. It's larger to observe tremor. We need more density for the station. This is the first, and maybe now the most simple things. If we have some temporary deployment, the 1 year in some place, we can observe many things. But at this moment, we have this deployment that occurred for the catastrophe of the 2010. And in these next 10 years, we don't have any other plan to improve our seismological network.
Well, okay. I'm just going to skip to the really simple questions because we're short on time. So what region of Chile is of most concern to you for a future great earthquake? That's the simple one.
Excuse me?
What region of Chile?
It's central Chile, because the last megatrust occurred almost 300 years ago. And I think that is the most important also because we have the big cities. And for us, at least for me, because it's more simple to deploy the seismological stations. And if we have, there is some project, I think the more easier is to put a station in central Chile. Also, this mega thrust earthquake is 7030 is looking now.
And I'm going to squeeze one last one in here, and then the rest of this is going to have to continue over email. But Jeff McGuire asks, can you tell us more about plans for offshore instrumentation in Chile?
There is some planning, but at the moment, the planning of the instrumentation offshore are also for some temporary deployment, in particular for the German people from Kiel, and also some groups of the United States from Antrejo group, but are also a temporary deployment. There is not a plan for deploy more consistent deployed of offshore instrumentation.
Okay, I'm tempted to let it keep going because this is all very interesting. Maybe one more. Could you answer Chris Rollins' question, perhaps?
Excuse me?
See that? Which is the Katamoy et al. 2019 paper proposes that the idea that the 1916 earthquake was accompanied by a silent Laquina fault zone event, but also speculates alternatively that it could have been a single event on the megathrust with a rake of 140. Which do you think is more likely, if either?
Yes, no, I agree. I read the comment on Professor Torley. Yes. I agree with this. It's more complicated. I don't know. I also give to say that the point is the Valdivia area is more complicated than we think. I don't know. It's only one date. Then the Professor Kanamori gives some alternatives, but we don't know actually how this earthquake was. The only observation I have is there is not surface deformation in the or land in the side of the Liquiñovsky during the Valdivia megathrust earthquake, and also there is not damage in these cities. The damage was concentrated in the cities that are more closest to the coast. Then also probably the Liquiñovsky don't move during the cosysmic of Valdivia, or was very deeper and slow sleep. I don't know.
To some extent, it's unknowable. And then, all right, this really will be the last one. Harold's question right at the end, which is, how does the precursory slow slip from 2014 and 2017 compare? Are they similar in size, magnitude, or duration, or do they scale with the main shock size?
For the 2014, the main shock was an 8.2, and the precursory slow sleep was around, I don't know, but around 6.7, 6.8, if I think. It's 2 orders of difference. And for the Valdivia earthquake, the main shock was 6.9, and the precursory, the slowest precursory, I also think that was on 5.9 or 6. It's a much shorter the relation. But also, we don't have we have the observation that there is some movement, but to obtain from this data the sleep distribution of the slow sleep, it's more complicated because the resolution is not good. But the movement is very, the magnitude moment is very lower in comparison with the main shock.
Okay, well, thank you so much for an interesting talk. Thank you everybody for coming and sticking with us a few minutes after the hour. I remind you again that this is going to be a continuing series of international subduction zone science. 2 weeks from now, we will have magmatic processes. 2 weeks after that will be landscape seascapes. And 6 weeks from now, which is August 28th, we'll have Shuichi Kodara talk to us again about earthquakes from Japan. So thank you very much, and hope to see you there.
Thank you. Thank you.